morning, students. Myself, Dr. Ramurthy Reddy, Assistant Professor, SV Engineering College, Tirupati. In today's lecture, we will discuss on complex analysis, differentiation, and integration. So, before going to that, in lower sections, we have a complex number, right? The necessity of complex number. The necessity of complex number is general in reanalysis, we have every equation as root, right? So then, x square plus 1 equal to 0. So this is an equation. For that you have a solution. So that means x square equal to minus 1. X equal to square root of minus 1. So there is no real value square root of minus 1. In that there is a necessity to introduce a complex number I. So I is nothing but square root of minus 1. So then they developed a theory, complex theory. So in that, we have a complex variable. So let it be z. Z equal to x plus iy, where x is a real part and y is an imaginary part, right? So, z is a complex number means we have a complex function z. So in terms of x and in terms of y. For that there is an image f of z, so which is indicated by w. So w equal to f of z, so which is u of x comma y plus iv of x comma y, where u of x comma y is a real part and v of x comma y is an imaginary part. See here, z is a complex variable and it can be written as, so z is of the form x plus iy, so where I is root of minus 1, so and its image is w equal to f of z, which is u plus iv. So u of x comma y plus iv of x comma, where u of x comma y is a real and v of x comma y is an imaginary part. Next, coming to definition, so limit and continuity. So we have a limit definition in real analysis. So that is nothing but a limit x tends to x naught f of x equal to f of x naught, right? Similarly, we have a limit definition in complex analysis. So that is w equal to f of z is said to be a limit L as z approaches a point z naught, limit z tends to z naught f of z equal to L. See, real analysis and complex analysis, the definition is same. So, but real analysis, we have a real line. So, in any direction, so we have a real line. So, along any direction, suppose if we take a point x, then x tends to, right? So, from right side also it tends to same unique limit. So in complex analysis, we have a circle complex plane. So real and imaginary plane, right? So in this we have limit exists if that is unique in all directions, since it is a complex plane. So that limit is unique in all directions. Any path it is unique. Whereas in real analysis, it is only real line along real line. So but a complex plane, we have real plane and imaginary plane. So that limit is unique in all directions in any path. So similarly continuity also. So the definition in real analysis and complex analysis both are same. But in complex analysis, we have to check in all directions. See for example, limit z tends to 1, z square minus 1 by z minus 1 equal to 2. So this is complex. So whereas in real analysis, limit x tends to 1, x square minus 1 by x minus 1 equal to 2. Right? So we have to show this. Suppose if you have an analysis, then x square minus 1 by x minus 1. See, when x equal to 1, so this function is not defined. Function is not defined. Then we have a formula x square minus a square is x minus a into x plus a. So then x minus a get cancelled. It is x plus a. When we substitute x tends to 1, it is 1 plus 1. So it is 2. Right. So that is real analysis. So coming to complex analysis. So f of z is this. Limit z tends to 1. So here also same, z square minus 1 by z minus 1. So it is also of the form a square minus b square, right? A minus b into a plus b, then it is get cancelled. Then limit z tends to 1, z plus 1. So here we consider along path. So when along x axis, along y axis, right? So for that it is limit x tends to 1, then y tends to 1. X tends to 1, then y tends to 1. So when x tends to 1, 1 plus iy plus 1. So it is 2 plus iy, right? So then you have to substitute y tends to 1. So then it is 2 plus I into 1. It is 2 plus I. So this is the path when x tends to 1, then y tends to 1, right? So similarly, we have an example. Show that the function f of z is z bar by z is not continuous at z equal to 0. See, first you have to check the limit exists or not, right? For that, so z is nothing but x plus iy. So z conjugate is nothing but x minus iy, right? So it's a conjugate of z. So then, so f of z is becomes z conjugate means x minus iy divided by z is nothing but x plus iy. See, we have to take along paths. Suppose z tends to 0 along x-axis. Along on x-axis y is 0, right? Y is 0. So then z becomes x plus iy. So since y is 0, z equal to x, so z conjugate equal to x. So therefore limit z tends to 0, z conjugate by z equal to limit x tends to 0, x by x along x-axis. It is 1, right? So similarly along y-axis, x equal to 0. X equal to 0 means then z is iy. So its conjugate is minus iy. Then limit z tends to 0, z conjugate by z is nothing but minus iy by iy. It is minus 1, right? See, along x-axis it is 1. So along y-axis it is minus 1. So it is not unique in two paths. Therefore limit does not exist. Then we don't want to go for continuous. See, differentiation. So f of z is u plus iv. So then the derivative of z, f of z, f dash of z is limit delta z tends to 0, f of z plus delta z minus f of z by delta z. This is actual definition. So reanalysis is same. So it is actual definition. Its value does not depend on any direction. See, in reanalysis there is no case. So but complex analysis, its value does not depend on any direction, right? Now show that the function. So this is your function, and delta z na delta x plus I delta y f dash sub z by using this formula. So you get this expression last. Now see the paths. Delta y tends to 0 when delta x tends to 0. So these are two different paths. So in two different paths, so the value is same. So therefore derivative exists and it is derivative. Now analytic function f of z is derivable at every point of z. See, analytic function f of z is derivable at every point of z, then the function is said to be analytic. For suppose f of z is e power z sin z cos z, everywhere it is differentiable. So those are analytic functions. For example, if you consider 1 by z, so it is not defined at z equal to 0, right? So z equal to 0 is nothing but a singular point. So therefore that point is not analytic. So we can say f of z is 1 by z is analytic if z not equal to 0. So when z equal to 0 it is not defined, so that it is not differentiable. It is not differentiable means it is not analytic, right? So through definition also we can check. So see, f of z equal to 1 by 1 minus z. So just a thing, when z equal to 1, so it is 1 by 0. So that means it is undefined, not defined. It is not defined means not differentiable. Not differentiable means not analytic. So right. So through the definition, it is C f dash of z, f of z plus delta z minus f of z by delta z. So here we take 1 by delta z as outside, and it is 1 minus z minus, in place of z it is z plus delta z, right? So by taking LCM we get this. See, when z equal to 1, it is not defined. So that means it is not differentiable when z equal to 1. So if z not equal to 1, it is differentiable, right? So that it is analytic. Now coming to integration. So f of z is nothing but u of x comma y plus iv of x comma y. See, f of t is nothing but u of t plus iv of t. So t is any variable. So we can represent z, t, p, q and so on, right? Now in any closed interval ab, you have to integrate. So integration is nothing but finding area. so over a to b or any region, right? So for that closed interval ab, it is integral a to b f of t it is, so it is a real part and it is imaginary part. So right, for this, see, line integral f of z is a complex variable defined on D. Let's see we any arc in the domain D. Then integral will see f of z dz is. It is u plus iv. It is dz. Dz is nothing but dx plus I dy. By multiplying this, you get this expression u dx minus v dy plus I u dy plus v dx. So this is like a formula. If you want, you can use. Otherwise, you multiply, then you get easily. Right? So this is line integral. The So one problem, evaluate this along y equal to 3x between the points. So along y equal to 3x between the points. From these points, you conclude this equation. See, when x equal to 0, y is 0. When x equal to 3, y is 9. So that means it is multiple of 3. So of course it is given. If not given, you have to use the formula, 2-point formula. So that is nothing but y minus y1 equal to y2 minus y1 by x2 minus x1 into x minus x1. It is two variable slope in slope form, right? So you can use that to find this equation, right? So if given, no problem, not at all finding this equation. Now the points are given. So equation of line passing through these points is they are given, y equal to 3x, then dy is 3 dx. Now see, to evaluate this integral, you have to change either total integration in terms of x or in terms of y. Suppose in terms of x means x varies from what to what, and suppose you integral in terms of y means y varies from something to something. So you have to change like that, right? See here, so they given y equal to 3x now. If you substitute y equal to 3x, the total integral changes to x in terms of x, right? Then x is varies from c. So the points are given 0 0 3 9. That means it is x1 y1 x2 y2. So that means x varies from 0 to 3. So 0 to 3 x plus, so you replace it y by 3x dx x square y by 3x. So it is dy na? Dy is nothing but dy is 3 dx. Huh? So then you multiply and simplify, you get so all everyone knows integration integral x power n dx is x power n plus 1 by n plus 1. This is a definite integral. You have to use limits also. So first upper limit you have to use, then minus of lower limit, then you simplify this, you get the answer, right? See next one. So evaluate some integral line joining. So here the line equation of line is not given, so you have to find the equation of line. See 1 minus I to 2 plus I. So this is nothing but 1 comma minus 1. 1 comma minus 1. X plus Iy na. X comma y is a point. So that means 1 comma minus 1. Here x plus Iy. X is 2. Y is 1. So for that only a equal to 1. A 1 comma minus 1. B 2 comma 1. Now the formula for finding equation of lines. Say y minus y1 equal to y2 minus y1 by x2 minus x1 into x minus x1. Then to substitute the points, y1 is minus 1, so therefore it is y plus 1. Say y2 minus y1, that means 1 plus 1 by 2 minus 1 into x minus x1, x minus 1, right? Then you simplify, you get the line y equal to 2x minus 3. So you need a dx plus I dy na. So you want to change either x or you can change either y, right? Means now here we are changing the total integration in terms of x. Then dy is 2 dx, and x is varies from, see the points, x1 is 1 to 2, x varies from 1 to 2, and substitute y equal to the line 2x minus 3. So dz is nothing but dx plus I dy. Dx is dx plus I into dy is nothing but 2 dx, right? Here we then multiply. So if you multiply and simplify, use a definite integral integration formulas, and using limits, upper limit minus lower limits, then you get the answer 4 plus 6i, right? Now we have theorems. So the important theorems are Cauchy integral theorem and Cauchy integral formula. See, Cauchy integral theorem is nothing but f of z is an analytic function on and within a simple closed curve C, and f dash of z is also continuous. Then integral f of z dz is 0. See, the statements, this is your f of z is well known. Be analytic. Analytic means it is differentiable on and within a closed contour C. So that means you have a contour C. So it's a closed contour, closed curve like. So you have a closed curve. In that, f of z is analytic on that curve and within the curve. Then f dash of z is also continuous. Then you conclude f of z is its integration is 0. Right? So whereas Cauchy integral formula, f of z is analytic within and on a closed contour if z equal to a is any point within C. See here it is analytic within and on the closed contour. So there is no point in outside the region, inside the region. See here z equal to a is within C. So that means your function is not analytic at z equal to a. That point is within C. Within C means then the formula f of a equal to 1 by 2 pi a integral f of z by z minus a dz, where integral is taken positive sense around the C. So it is positive sense. See the difference is there is no point inside the region. So here is a point inside the region. There is no point inside the region means we use Cauchy integral theorem, it is integral is 0. So if there is any point which is lies inside the circle means we use Cauchy integral formula. Right? So based on this we have a problems. So now Cauchy integral theorem is nothing but the function f of z is analytic. There is no point which is lies inside. If there is any point lies inside the circle means we use Cauchy integral formula. Right? See the problem. F of z is nothing but this. Right? So the given circle. So z is z mod z equal to 1 by 2. It is nothing but z is centered at origin and having radius 1 by 2. Having radius is 1 by 2. So the singular point f of z is, this is not, so it is not defined at z equal to 1. Therefore 1 is nothing but singular point, and that 1 is outside the region. So because you analyze the circle with radius 1 by 2, this point is outside the circle, or otherwise you substitute in modulus of z. So in modulus of 1, 1 is greater than 1 by 2. So therefore it is outside. If it is less than the region, then it is inside. So see, this is totally analytic except at z equal to 1. Okay. So that 1 is outside the region. So now easily apply Cauchy integral theorem. Its integral f of z dz is always 0. Right? See next problem. Integral c e power z by z minus 2. So this is your f of z. F of z is nothing but e power z by z minus 2 dz. So where circle is given, see modulus of z equal to 1. Modulus of z equal to 1. So this f of z is analytic except the point z equal to 2. Now you need to check the point whether lies inside or outside. Since given circle is mod z equal to 1, this is a circle with a center origin having radius 1. So the singular point is 2. 2 is clearly outside the region. Right? Or you substitute modulus of 2 is 2. 2 is greater than 1. Therefore the point lies outside. So by Cauchy integral theorem, we can say that its integral is 0. Right? Now let's see the next problem. Evaluate this problem. E power 2 z by z minus 1 z minus 4 where c is mod z equal to 2. See mod z equal to 2 means there are two singular points. This f of z is, if we consider f of z is this, it has two singular points z equal to 1, z equal to 4. Therefore the function is not defined at z equal to 1, z equal to 4. 1 for a singular points. Now we need to check which point lies outside, which point lies inside. Right? So if we substitute 1, it is modulus of 1 less than 2. that means it lies inside the circle. The z equal to 1, the singular point z equal to 1 is lies inside the circle. And if you substitute z equal to 4, modulus of 4 is 4, it is greater than 2, so that means the point lies outside the region. So we have two singular points in which one point lies inside, one point lies outside. So now which point lies outside, you have to mention that in a numerator. See, z equal to 4 lies outside, therefore you mention that is outside. That means e power 2z by z minus 4 is numerator and the denominator is z minus 1. So this is of the form f of z by z minus 8 dz. Now compare this with f of z is nothing but e power 2z by z minus 4, and your singular point is z equal to 1. So see, z equal to 1 is a singular point which lies inside the circle. So inside the circle, one point lies inside the circle, then you have to use Cauchy integral formula. So if there is no singular point inside the region, means we have to use Cauchy theorem, Cauchy integral theorem. If there is a point lies inside, means you have to use Cauchy integral formula. So which is nothing but integral f of z dz is 2 pi I f of a. A is nothing but 1, f of 1. So f of z is nothing but e power 2z by z minus 4. Now we substitute e power 2 into 1 by 1 minus 4. It is minus 2 by 3 pi I e square. Right? See, uh, so we have one point lies inside, means you have to use Cauchy integral formula. There is no point lies inside, means you have to use Cauchy integral theorem. So you have a point lies inside, so but it is multiple point, that means singular points are 1 comma 1 comma 1 comma 1 and so on repeated. Then you use Cauchy generalized integral formula. See the theorem, f of z is analytic function within and on a closed contour if z equal to a is any point within C, then fn of a is n factorial by 2 pi I into f of z by z minus a whole power n plus 1 dz, where the integral is taken in the positive sense around C. See, one problem is also there. uh, Given integral is given. See, the singular points are z minus 1 equal to 0, z minus 2 equal to 0, z equal to 1, z equal to 2. So therefore 1 comma 2 are singular points. Now you have to check which point lies inside. If we substitute z equal to 1, modulus of 1 is 1. So which is less than 3, that means the point lies inside. If you substitute z equal to 2 here, modulus of 2 is 2, which is less than 3. So see, both 1 and 2 lies inside. Suppose one point lies inside, means you use Cauchy integral formula. There is no point lies inside, means you use Cauchy integral theorem. Here two points are inside. So in that cases, you have to use partial fractions to split. So you have to use partial fractions. Say 1 by z minus 1, z minus 2. So already well known in lower sections, it is how to split the this 1 by z minus 1, z minus 2 as a by z minus 1 plus b by z minus 2. Now taking LCM, this 1 equal to a into z minus 2 plus b into z minus 1. Now put z equal to 1 in the above equation. This equation you have to substitute z equal to 1. Then 1 equal to a into 1 minus 2, it is minus 1 minus a, it is 0, right? So a equal to minus 1. Now similarly put z equal to 2, this term is 0. Then it is 2 minus 1 is 1, b equal to 1, right? Then substitute a and b values. 1 by z minus 1 into z minus 2, it is minus 1 by z minus 1 plus 1 by z minus 2. Then your required integration is e power 2z by z minus 1, z minus 2. It is e power 2z by z minus 2 first. See, this minus is there, right? First you write z minus 2. Then it is minus e power 2z by z minus 1 dz. Now you separate, you find the integral separately for this. Since z equal to 2 singular point lies inside, means then only one point lies inside, means then you have to use Cauchy integral formula. Integral f of z by z minus a dz is 2 pi I f of a, right? So I used this here, 2 pi I f of 2 right? F of z is nothing but e power 2z. It is e power 2 into 2 is e power 4. So this is one, right? Now separately you consider another e power 2z by z minus 1. Z equal to 1 is a singular point which lies inside. By using Cauchy integral formula, it is this, right? Then you combine, you get the answer. See, next one. So this is, you have to evaluate integral c log z by z minus 1 whole power 3 dz, where c is mod z minus 1, which is equal to 1 by 2. So this is a circle with center 1 comma 0 and having radius 1 by 2. So this is your function, and you have a singular point z equal to 1. At z equal to 1, this function is not defined. So when z equal to 1, it is infinity. So therefore it is not defined at z equal to 1. It is also 1 1 1 3 times repeated, right? Now we need to check this point lies inside or not. So what I say is, substitute z equal to 1. So if we substitute z equal to 1, it is 1 minus 1, it is 0, right? Modulus of 0. Modulus of 0 is less than 1 by 2. So that means that point lies inside the circle, right? So that point lies inside the circle. So see, z equal to 1 lies inside the given circle. Now by Cauchy generalized formula, so which is integral c f of z by z minus a whole power n plus 1 dz, so which is 2 pi I by n factorial fn of a. So but that it is, you compare with n plus 1. N plus 1 equal to 3 means n equal to 2, right? 2 pi I by n factorial is nothing but 2 factorial f double dash of 1, right? Now your f of z is log z. Now you differentiate f dash of z is 1 by z. Again you differentiate, it is we have will know d by dz of z power n is n into z power n minus 1. So that our formula, that formula I used here, 1 by z square minus 1 by z square. Then you need f double dash of 1, f double dash of minus 1 by 1 square, so which is equal to minus 1. So it is integral c log z by z minus 1 whole power 3 dz, so which is equal to 2 pi by 2 factorial into minus 1. After simplifying, we get the answer minus pi, right? So with this I complete the lecture, right? I thank to the coordinator Dr. Surendranath Reddy and Rupali S. Jain madam for organizing a faculty development program on SRTM University, Nanded. So thank you madam. Thank you sir.